Moment of inertia, one of the fundamental topic in physics. It is also called rotational inertia and it is equivalent to mass in linear system. Like the amount of force we needed to displace an object in linear system is depend on the mass of the body. Same way in rotational motion, how much force or how much torque is applied to the body so that to rotate it. It depends on the moment of inertia. So we can say moment of inertia is an equivalent to mass in linear system. So hello everyone, welcome to the channel Math Meet Physics. Let's see the definition, and in this video we will derive this formula of moment of inertia, which is equals to summation of mi/ri square, where I start from 1 to n. So first of all, let's see the definition. Moment of inertia, denoted by the letter I, is a measure of an object's resistance to changes its rotational motion about an axis. It depends on both the mass of the object and how the mass is distributed relative to the axis of rotation. In simple terms, it's the rotational equivalent of mass in linear motion. So this is the formula of moment of inertia. It depends on two things, mass and how mass is distributed. So when we open this summation sign, it will like this, m1 r1 square plus m2 r2 square plus m3 r3 square and up to mn rn square. Here n represent the total number of particles in this body, which is n, and m1, m2, m3 are masses of the particular particles and their corresponding distance from the axis of rotation. Now we will see how this formula appears, and the basic idea is we are going to compare the rotational kinetic energy with the linear kinetic energy, and we will see how mass is equivalent to that formula. So the moment of inertia is derived from the basic principle of rotational motion. So translation kinetic energy is equal to half mv square. Consider rigid body rotating with a constant angular velocity omega about an axis passing through the point and perpendicular to the plane of paper. Now you can see this diagram. There are masses represent m1, m2, mn and their corresponding distance from the axis of rotation. Each mass is rotated with constant angular velocity omega because they are contained in that body. But due to their difference in radius, like m1 is at r1 distance from axis of rotation. Similarly, from axis of rotation is r2, and for mn, the distance is rn. So due to their different in radius or distance, their linear velocity is different. So each particle moves with a constant angular velocity but different linear velocity. So we have a relation also between v and omega. So v is equals to omega r. This is a relation for linear and angular velocities. Now let m1, m2, m3 up to mn be the masses of the particle situated at perpendicular distances r1, r2, r3 up to rn, respectively from the axis of rotation. Here summation of mi represent the mass of the body, which is capital M. As we discuss, all particles move in a circle with same angular speed omega, but with different radii about the axis of rotation. Therefore, linear speed of the particles are different. Let linear speed of particle of mass m1 is v1, which is equals to omega r1. Kinetic energy of particle of mass m1 will be half m1 v1 square. And since v is equals to omega r, so we can write in place of v1. So it will be half m1 r1 square omega square. This is kinetic energy of first particle of mass m1. Similarly, kinetic energy of particle of mass m2, m3, m4 and mn is half m2 r2 square omega, half m3 r3 square omega, and likewise half mn rn square omega. Now the idea is the kinetic energy of the whole body is equal to the sum of kinetic energies of individual particle. So kinetic energy of rotation will be sum of all kinetic energies. So we can write the equation like this, and you can see in this equation half and omega square are common terms, so we can take it out. So half omega square common, and the left part is m1 r1 square plus m2 r2 square plus m3 r3 square up to mn rn square, which can be written as summation of mi ri square. Here I start from 1 to n. So this is the kinetic energy of rotation. Now we are going to compare this equation with linear motion or linear kinetic energy. So kinetic energy of body in rotational motion is half omega square summation of mi r square, and kinetic energy of body in linear motion is half mv square. On comparing these two equations, we can see v square is omega square and half is half. So the term m in linear motion is equivalent to the summation of mi r square. So the mass m in linear motion is equivalent to summation of mi r square, and this term is called moment of inertia. So mass in linear system is equivalent to moment of inertia in rotational system. Thanks for watching. For more videos, please subscribe and support our channel. Thank you.